Hello friends, in today's video lecture we are going to learn about fixed point scaling. In earlier video lecture we already discussed what is scaling. Scaling is used to resize the object. Now when we used fixed point scaling, it is used when we require scaling of object but particular point must be at its original position. At that time we can use fixed point scaling. Now let us see how fixed point scaling can be done and what are the metric equation for it. Let us see fixed point scaling. Suppose we have three plane, that is x axis, y axis and z axis. Now what is fixed point scaling? Suppose I have this 3D object and I have to these have A, B, C and D point, right? So suppose I have to scale fixed point scaled from A point, right? So I have to scale this object from only A point, not to move all object, right? So suppose I have to scale resize that object from A, then it will be look like this, right? So I fix that point A and scale or resize that object. This is a fixed point scaling, got it? And fixed point of this 3D object, that is point A. So this is the figure of fixed point scaling. For this fixed point scaling, matrix can be obtained in 3 steps, right? First step is translate the fixed point to the origin. First step is translate the fixed point into origin, and second step is scale the object relative to the coordinate origin using coordinate axis scaling. And third, that is translate the fixed point back to its original point or position. So what we have to do? First translate the fixed point to the origin, then scale the object relative to coordinate origin and translate the fixed point back to the origin. So what will be the equation for this? That is equation of this fixed point scaling is P dash is equal to, what is our first step, that is translate. So T into scale the object relative to the coordinate origin. So T into S into again T into P, because we have to translate the fixed point back to its origin position, and last into P. So we know that our value of T, that is 100 x 0 1 0 yf means y fixed point, x fixed point, 0 0 1 z fixed point, and 0 0 0 1. This is our first T. Translate the fixed point to the origin, right? That our first step. Now second step is scale the object relative to coordinate. So Sx, Sy, Sz and 1. So 0 0 0 0 Sy 0 0 0 0 Sz 0 0 0 0 1. This is the formula for S. Now T into T means which T? Translate the fixed point back to its original position. So what we have to do, we have to we already have translation equation, and suppose it scaled and re back to that position. So for that we have to take negative value of x, y and z coordinate. So this T, value of this T, step number 3, that is 1 0 0 minus xf, 0 1 0 minus yf, 0 0 1 minus zf, 0 0 0 1, right, into point P, right. So this is our final equation for fixed point, right. Now we have to calculate one by one, calculate this matrix. First we have to do T into S, then whatever answer will be, that it will be into T, and finally into point P. So final equation for P dash is equal to Sx 0 0 1 minus Sx xf. I am writing the direct answer because it consumes lot time to solve the matrix, and you all of you know how to solve the matrix. So I am writing directly. And third, that is 0 0 Sz 1 minus Sz Zf, right, and last 0 0 0 1 into P. So this is the final formula for fixed point scaling. So this way we can solve fixed point scaling. Now I hope you clear with fixed point scaling. Thank you for watching.